Well, without further ado, I want to welcome everybody to the TMAC, that's the Modern Airport Conference, in joint collaboration with iPort. The iPort Conference, this collaborated webinar today, we will be speaking on how digital twin technology impacts and affects the future of airport and port operations. We're going to take a closer look at a use case study on what's going on with this technology in the Changi Airport there in Singapore. And to discuss this more fully, we have Eric Liu. Eric is the CEO of Digital Twin Technologies. And did I get that right, Eric?
Twin Matrix.
Twin Matrix. I'm sorry. I'm confusing the technology with the company name. Apologize.
No worries.
But Eric's going to be here talking with us about what his technology, his team, and his company in Changi. And Eric, before I turn it over to you, I just want to talk a little bit about some of the couple of the things that I've recognized in our discussions and our evaluating all of this, and the many meetings that I've had, some with you, but also with your team, and in particular, Chris Williams, who works with you on this.
Right.
I've looked at how the potential of your technology and your platform, especially in terms, Eric, of how it can increase and have an effect on everything from airside air traffic management to improving efficiency on the land side and air side, making airports safer, having more, improving security, having an effect on the revenue outcomes when you start looking at how it can be used to improve the retail opportunities in an airport. Maintenance, even in maintenance operations, it's a tool for asset management. So today, I just kind of want you to go through. I'm sure I missed something, but where it's at now in terms of its deployment as a technology in the Changi Airport, what you guys have recognized, the clear benefits. But then also later, I'm going to beg the question of where do you see this going, the potential future development of this technology, because I'm sure this is not something that's going to stand still. It's going to be an ever-evolving thing in airports and ports. So, Eric, without further ado, I will hand it over to you. Welcome, and we thank you for your time here today. And we're excited to learn as a group about this new technology that's modernizing our airports and our ports. Eric, welcome.
Perfect. Thank you so much, Jerry, and really appreciate the time, everyone, today. I'm really excited to be here and discuss and also showcase a lot of the things that we've been doing in and around Singapore, as well as various other countries. So please allow me to share our deck so you can actually see this, because the way that I like to do things is actually to showcase, right? Not to just talk about it, but it's really about the understanding as human beings of how we interact with the physical world. So first of all, who am I? As Jerry mentioned, I've done various startups. This is actually my fourth startup for Twin Matrix Technologies. And surprisingly, I worked in the video game space about 20 years ago. So it's been quite a long time. And if people heard of the game called Diablo, I worked with the creators of Diablo 1 and 2. And I've always believed that this type of video game technology will scale into the professional industries. And over the course of the last 2 decades, I've been building all sorts of various use cases centered around this type of technology. At the same time, everybody's probably by now heard of a company called NVIDIA, because NVIDIA is actually the backbone of not only AI, but previously it was actually the backbone of video game technology, and even now. So the key thing is that, I do a lot of, discussions around the world, but the key thing today that I'm going to focus on is actually what digital twins are utilized for, especially when it comes to airport and port operations. So the twin matrix technology is actually the intersection between technology, human-centric design, and the built environment. And when we think about digital twins, right, maybe some people are probably heard of it, but I think it's really good to really understand what it is, right? Even from a dictionary perspective. And a digital twin is a digital replica of a physical object, person, system, etc. So the way that we actually see things, it's a digital representation of not just an item, right? Let's say an engine for an aircraft or a ship, but is actually the space itself. Because we as human beings operate in spaces, whether you're in Colombia or Brazil, Latin America, China, US. Right now, I'm actually situated in Singapore. It's midnight over here. But the thing is, things keep going. And when we talk about the spatialization technology, this is where it all leads to. So digital twins really encapsulates the digitalness of the physical world, right? When we think about sensors, motors, and all of that, very mechanical things. But because of IoT, right, Internet of Things, and because of, right, if you think about it, it's really just a dumb sensor adding a Wi-Fi or Bluetooth uh, signal so that you can actually connect and understand where it is and what it's doing. And at the same time, when we think of spaces, we think of all sorts of different departments that operate in these spaces, whether it's at ports or airports. So when we think about the digital twins, right, we see that it's about logistics at the same time, because at the end of the day, we're still moving physical goods throughout the world, from the sea, right, across the world, all the way through the air. And of course, in the middle, there's something called cities, which if you think about it, a city is actually just built by buildings, different buildings connected, sort of like Lego building blocks. So when we think about how to apply these digital twins, it's really critical to not only understand the philosophy behind it, but also the applications. And that's what I'll talk about today. So why should you care? Well, the global digital twin market is increasing exponentially. It's increasing every single year, and it's being important to understand not only what it is, but how it's applicable. Because how does it affect you? Well, surprisingly, for airports and ports, it's one of the fastest growing segments in the digital twin market. And what are the benefits? Well, just like Jerry said, operational efficiency, predicted maintenance, emergency preparedness, and a bunch of other things. But of course, where's this from? Isn't this just a generic ChatGPT response? And then some of you are probably thinking, well, I'm a little annoyed. Why is it just ChatGPT? I can ask AI a question anytime. How do you actually apply it? I'll show you. So before we get into that, we need to understand what spatial means, because the key thing that I've learned over the last 2 decades of building these things is actually digital twins, right? When we think about it, a lot of even real estate industries talk about digital twins, and then they scan a place and they say that's a digital twin. However, my definition of that is actually different because it involves spaces and relationships. So what we believe in is the future of spaces is increasingly connected. And when we look at it from this layering perspective, we built something over the years called Spatialverse. And the physical world must be mapped with a digital version of a 2D or a 3D map. And this digital map, we realized over the years, is that it must be maintained by their respective owners. We need to basically have just like in the real world right now, just like in every single industry, every single enterprise, every government maintains their own data across different departments. And then once that actually is maintained by the respective owners of the data, then you can start overlaying all sorts of additional layers. So whether one of the use cases, navigation, right? Whether it's traffic patterns or whether it's air traffic control or whether it's autonomous vehicles inside the ports, all of that is critical to having that digital map layer. And then, of course, you overlay IoT, integrated operations, and of course, you can have location-based experiences for, let's say, even end customers of airports. So without further ado, I'll showcase some of the projects we've done over the years. And I think this is going to be very striking because I'm going to quickly go through various different use cases of spatial digital twins. So You can see here, this is actually the first one's a smart city we did of Shanghai. And this is actually the Bund area. So I'm going to stop and talk through this because we digitally replicated the entire Huangpu district in Shanghai since I was there for about 8 years. And this was actually done for the police department. And here's the drone footage where we actually flew a drone of the real Bund area if ever anybody's ever been there. But to actually recreate it digitally, to have a 3D map and then overlay IoT and real-time telemetry, as well as CCTVs, was really critical. So my first startup, Unisol, we started looking at the combination of different data points of 3D as well as 2D models, and then, of course, overlaying it with over 300,000 CCTVs. And this is really critical because, you know, when we think about China, we think about a lot of CCTVs, and it's true. But at the same time, how do people actually access CCTVs, right? If you actually access a video management system at your airport or port, it's literally a spreadsheet of IP addresses. And that doesn't make sense to the normal human being. But once you start mapping this in a 2D or 3D space, it becomes a lot more understanding of where things are connected. And then, of course, we start moving into the smart buildings. So we started building smart buildings. But the key thing is, it's not only just about tapping into telemetry, IoT, carbon monoxide sensors, even the CCTV of car park, the parking lots to see if the cars are registered with the university or not. But at the same time, the key thing about not just visualization or a dashboard, it's really to control the physical world. So back in 2021, during COVID days, we built the first fleet management system in Singapore. And this was really useful at the time because during COVID days, it's really hard to move things, to go to that space. So I'll never forget that I was actually in Silicon Valley and I logged into the AWS GPU cluster that was running this. And I moved this specific UV robot over to this grid, right? And this is using a 3D video game engine. But then you look in the CCTV and you see that it moved there. And I turned it on. And immediately there was a PhD student sitting there, and she freaked out and ran out of the room. And immediately back then I knew that, you know what, this is going to be the key to a lot of upcoming physical spaces. And we're seeing that happening as we speak with all sorts of robotics, even humanoid robots being rolled out this year and next year. So fleet management of all of these different data silos is really critical. And we even applied this to retail spaces. So you'll see in a second with Balenciaga, we did a proof of concept for one of their stores in Singapore, and we spatialized it. But at the same time, we also tapped into the CCTVs to understand the footfall of people. But at the same time, we not only did heat maps, because everybody's seen that before, but it was 3D heat maps. We started upgrading it later because in the physical world, right, it's a 3D environment. It's not just a 2D landscape. And at the same time, we also tapped into the inventory management as well as the point of sale systems to understand the spatial intelligence. But the biggest lessons learned of building these 3D digital twins over the years is that 3D is not very scalable. It's really good for a command and control center, but especially for retail, these things change. Right? Somebody moves something or they buy something, or if the store wants to change the display every day or every week, how do you maintain that? So we realized over the years of building these things to create the tools necessary to allow every department to update their own data. So we call that the democratization of the digital twin data updating. So you can see here how if the maintained the 3D or 2D digital twin is there, you get a lot of insights into it. And we really also applied this to critical infrastructure as well, water treatment sites. We're running multiple water treatment sites on a 3D digital twin right now because it's used in a command and control center. But the key thing is this was for security, safety and security, actually. So you can see here, I'll scroll back, where it's not just a visual representation, but it's real time using a command and control center to pull different feeds of different various sites. But then to also keep people safe, because when you can actually understand that people are walking where they are they registered with the water treatment site, things get more automated. You don't have to have a security guard waiting there, right? Because now of access control and all of that. But at the same time, we also tapped into wearable biometrics. So what does that mean? Well, we actually had the contractors, every single one of them, wear a wearable. And then if they got into any issues, they would just click an SOS button. And on the digital twin operating system, it would actually tell them that, hey, there's somebody there, and they'll click through the CCTV. So the operator clicks on the CCTV and jumps from CCTV to CCTV. And this is 360-degree one, so you can actually rotate it. And I like to say that this is a representation of sort of like Google Street Maps, or Street View, but it's actually live because this is their data, right? They can tap into their own video management system. And this really was profound because this enabled a whole new understanding of the space. And then, of course, the key thing about a digital twin from a safety security perspective is that, well, all of the IoT, including CCTV, can be synchronized to, let's say, something that happened last night. And this is the 4D element, not just 3D. 4D is time. You can roll back time, synchronize everything to last night at 8 p.m., and you can actually walk through it as if you were there. So there's a lot of use cases that we've been building over the years. And even going back to the Shanghai example, you can see here, we actually installed a bunch of CCTVs pointing down on the Bund area, right? So this is a smart city application. And of course, this can be applied for airports, ports, any space. But then we actually streamed it live. So just like if as if you're a bird, you're flying around in the 3D digital twin, and you can actually see exactly what's happening with your space that you're managing. And this was actually profound as well because it enabled almost superpowers for the operators of the digital twin. So when it comes to all of these, right, everything starts with a vision. So I'm going to start going a little faster because now you see what we've actually done, and now you can understand where this is going, because 90% of information is through the brain, and really, for vision is through the brain. And when it comes to human-computer spatial interaction, like I mentioned before, physical and yet the digital layer, but digital layer is really just zeros and ones communicating between various different IoT devices. But then how do we as human beings interact with it, right? So I always like to show this because back in the 80s, right, we started with fax machines and we started with all sorts of other physical objects. And then, of course, as the 90s came up and digitalization started happening, a lot of these companies, like internet companies, came to be, but then all of that data was eventually became in the palm of our hands, right? An atlas, before we had globes, now there's Google Maps, there's Apple Maps. And this is where things are heading. And this is actually previous, but now I will talk a little bit about how AI comes into effect as well, because that's on everybody's mind these days. So back in the day, right? And now it's a whole new world. And because not just consumers, but also enterprises, ports, airports, smart cities, it's all in data silos. And because we had so many evolutions of economies over the course of human history, right? From farming all the way to technology, and now the digital economy and the connectedness, this is the time now to actually start thinking and focusing on how this all connects together. Because we all heard about Industry 4.0, but what does that even mean, right? Well, cyber physical systems is essentially a digital twin, a cyber and physical worlds colliding. And the encapsulation of IoT, Internet of Things, networks, AI, and robotics. And this is really moving towards next generation. And we have to mention AI, right? And I use this because just to show that things, even in 2 years ago, because we're in 2025, was already at the human baseline. And we all know what's happening right now as we speak. It's actually surpassing human intelligence. And I'll talk about that and how this applies to digital twins very soon. So rolling back, when we look at the pain points of these seaports and airports, surprisingly, it's the same challenge. Because at the same time, we talk about siloed systems, right? Whether it's just CCTV or terminal operation system or something else. All of these are data siloed right now. It's great that it's being digitized, but it's not being connected properly. Limited AI capabilities. How do you even apply AI? How do you even utilize AI? AI is a tool. It's supposed to spit you out more information, but you need to make sure that this is all connected first into a common machine language, and then AI can understand it and make suggestions. And there's a lot of other challenges: asset tracking, safety limitations, visualization capabilities is really critical. And this is why I talk about visuals. So quickly to look at some use cases around the world, and I'll showcase what we've done with Changi Airport. So Schiphol is actually has been actually demonstrating the use of a digital twin technology. However, it's not very visual from what I've seen because it's really a data-driven organization, which is great. But at the same time, it's about, well, how do I understand it, right? How can every single department management, as well as the people on the ground, benefit from a digital twin? And this is something I'll showcase very soon. And of course, when we talk about ports, right, back in 2020 in Egypt, the Ever Given caused a massive delay. And you know what? If the digital twin technology was applied, if there was a simulation, because something that a digital twin can also achieve over time is also to simulate the what if scenarios, and I'll showcase that in a second as well. And this is where we see the digital twin use cases across. It's applicable across the entire life cycle of a port, of when pre-arrival happens, all the way to arrival, to operations, to security and departure. This is the same thing in airports as well, right? It might just be different objects, different trucks, different baggage handling, but all of this is extremely relevant. So another example is actually the Port of Rotterdam, right? And this was even in 2018. There's a webinar given about this, talking about the fourth dimension, right? Because in the real world, it's all 3D, right? Why do we have to operate in 2D? And I'll talk about why 2D is also important a little bit later. However, the 4D element of space and time. So if you think about it, right now with IoT, it's saving all of this data. You have the whole historical data. I mentioned earlier, we have a technology called a spatial time machine, where you can rewind time and then walk through the digital twin and the 3D digital twin as if you were there. And you click on every single IoT because it's synchronized, and you can do forensics. You can get a better understanding of what happened. But of course, when we look at the real time, that's really critical from an operation standpoint, right? Then you can look at how do we optimize what if scenarios in terms of the prediction and simulation. So we have the before, we have the current, and we have the future. And this is what a digital twin can achieve if done correctly. And another reason why I moved to Singapore is because not just because Changi Airport is one of the top in the world, but also ports, right? You look at Tuas Port. Singapore has announced that they're going to be working on in the next 20 years, the world's largest fully automated port. But what does that mean, right? You need all of these digital data silos to connect, to understand it, right? Are you just going to let your port just run off and do its own thing? No, we need to verify, right? It's just like, for example, if I put myself in, let's say, Tesla, an autonomous car, do I trust that car right now? Let's say right now I order an Uber or a Grab, and a Tesla comes to pick me up and no one's driving. Will I put my entire family's lives at stake right now, given the fact that I'm not a fully 100% convinced yet? So this is why we have to, as human beings, understand all this data first and foremost and visualize it. So I'll showcase what we've done actually with a spatial digital twin port with my previous company in China. And what we've actually done was to tap into the terminal operations system to dynamically generate every single container. So I'm going to pause. I'm going to actually go through this because this is very important. So it's not just a visualization where you can mouse over every container, which is pretty cool to begin with, and see what the contents are, essentially where it is. Whoops. But at the same time, after we actually created this, we realized there are some very strange things that are happening. So if you look over here, there's some floating containers. So I believe the TOS system, the terminal operations system we tapped into was Naviz. It's a US-based company. But I guess what happened is that they didn't know that there was data issues, right? Because a TOS usually is in 2 dimensions. And without understanding where that data actually is, it's really hard to visualize. And once we actually generated all of these containers, this became very apparent that this was a data integrity issue. And they basically did an audit of their books after that. So this was an immediate use case, even just basic visualization. But over the years of building port digital twins, we also started doing additional things. So for example, we started tapping into the CCTVs over here. You can see, so this is actually one of the ports in China. And from a command and control center, it's a quick understanding of the entire port. and clicking on the various CCTVs to access those CCTVs live, right? And also spatially understand where does it cover. The coverage is important because once you have that, and if you have more coverage, you can start applying additional algorithms and AI to it, which I'll showcase with our partners at NVIDIA. So even just the basic elements of mapping it, right, from a 2D or 3D map to integration of various different data silos like CCTV is already enough to present you something like this, which is the third phase of what we did with the port. It became a complete operation system to understand everything that's coming and going, to also look at potential optimizations. I mean, we even got to the point where we were looking at employees and who operated what, right? And so, of course, from an HR perspective, it's very good. It's like a leaderboard from a gaming perspective. But the key thing here is to get a holistic view of the entire port. And not just the visualization, but overlaying data visualization. And that's really one of the critical things I like to talk about is that there's so much data. Like, how do you even make sense of it? Right? Are you going to download a CSV file and go through an Excel spreadsheet, millions and millions of lines of data? No, we're human beings. We can't process all that information. But what we can do is visualize it. And we're using new ways to visualize how do we potentially optimize, right? But the optimization is not only through algorithms, it's not only through, let's say, very, very experienced individuals, but these are spatial problems, right? One of the key things when we were talking to port operators is how do we fit stuff into a container more optimally, right? This is essentially 3D Tetris, one of the hardest things ever, but it's extremely important. And this is something where AI will be able to help a lot of the optimizations. But number one, you have to connect all the data elements and visualize it first and foremost and play it back and to learn from it. So we've been doing a lot of these various use cases. And I guess before I keep going, Jerry, anything from your side you want to quickly mention before I show some live demos?
No, I'm enjoying this. It's always a masterclass, Eric, with you. And I will remind everybody on the call that as this goes on, you can post questions for Eric.
Anytime.
And then I'll go over those questions with him. But no, this is great, Eric. Continue.
Perfect. So the way that I like to do presentations, and you probably, people who actually follow me understand this, is that I don't just show, talk through decks, and I don't just do video demonstrations. I show live things. So this is really critical from a digital twin perspective. So I'm going to jump over here now to the browser. And is this coming through, Jerry?
Yes, we can see it.
Perfect. Okay, so the key thing about Spatialverse that I mentioned is that it's an operation system essentially that manages a lot of the different data silos. But the key thing here is I'm going to show you basically flying down to Changi Airport from a 2D maps perspective. So give it a second because it needs to stream in a lot of the different data elements. But the key thing here is it's browser friendly. And I mentioned a couple of things earlier is that 3D is very hard to scale, right? You have to have very expensive NVIDIA GPUs, or if you're a gamer, you already have one. But the key thing here is browser-based technology is good enough to understand the spaces as well as the different data layers. But the key thing here is that, you know what I can do in 3D, I can also do a lot of it in 2D. So let's say we go into Terminal 1, right? And I can click on various different elements. So let's say even this duty-free shop over here, or actually, let's see, Burger King. Everybody knows this brand. And I can access a lot of the various different data elements. But at the same time, I can also go over here and understand, let's say, what if there's a CCTV? What if I have access to that CCTV? What if I'm able to stream it directly and see it live? And I could be anywhere in the world to access this. What if I'm able to say, well, what if I can map out every Siemens sprinkler system and fire alarm so that when firefighters come in, they know exactly spatially where everything is? And this is the key thing about all the various different data that we can map. And this is the key thing where even it works across entire iPhones, any Android devices, and it's for people on the ground. It's a spatial collaboration platform for people that are doing their jobs and not just looking at maps all day long. For example, over here, we can look at the metadata of, let's say, this fire extinguisher. We can map it out. And if this thing moved in the physical world, they can quickly just drag and drop it on their phones to say this is maintained because it's their jobs. Every single 30 days, every month, they have to go around to every single object. Might as well maintain the digital twin as they're walking around. So the key thing here is that as long as this is maintained, then we can start applying this to all sorts of various use cases. First and foremost is actually consumers. So for example, at changiairport.com, you click on this, and this is a live version of the maps of the digital twin for consumers. And I can click through, I can search for Burger King. Everybody's seen this before. But the key thing that you probably don't understand is that a lot of this is modifiable. We have the whole entire editor online. So let's say if Burger King wants to extend this out, we allow them to modify the structure, the digital version. Because as soon as that happens, they modify it, the cleaning robots can potentially go around this new perimeter because it's reading live from these maps. And to actually take it a step further, now I'll show you something that is essentially from not only air side, but also in terminal side. We call it Amplify. So Airport Management Platform, AMP. And if we go down to look at the holistic view of the airport, right, we can map out all sorts of data points, even live vehicles on the air side, as well as pull up their maintenance schedules, asset tracking, management. This is a holistic view of everything that's happening at a glance. And even just looking at this, right, just the colors, I can know that this gate needs maintenance. I can know that who actually did it previously. And if we want to map out live telemetry, you can. And this is the beauty of having something that's so fluid and useful and easy to use. Because like I mentioned, with iPhones and smartphones, that really changed the way that we interacted with the internet. I can even go indoors and see heat maps. I can see where potentially where bottlenecks are. And we're applying AI drivenness to understand, oh, is there overcrowding? Because as a human being, I wake up, let's say I go to work at 8 a.m. I want to be notified of all the changes, all the issues, right? I want AI to do that for me so that I can perform my job better. So this is the key thing where the more data layers that you overlay, that you connect onto a digital twin, the more that you're capable of doing. It gives you superpowers. And even with the simulation parts, right? The key thing about safety from an airport perspective is potential collisions. So if I know that this aircraft is pushing back, and I know that there's either a driver using one of our maps or an autonomous vehicle that's going here, we have a digital mirror to give early warning systems so that the operator can actually quickly change their tactics. So again, it's just a digital mirror at the end of the day. And it helps a lot, and it's very scalable for various different use cases. So now it's about, from my perspective, when we talk about spatial digital twins, let's say there's an issue over here, right? Some gate. How do I jump into that, right? And we're starting to experiment and also work with airports to do simulations to optimize. Because if you think about it, Changi Airport, right, one of the top airports in the world, there's 4 terminals. But over here, they're building Terminal 5 in the next 5 to 10 years. Terminal 5 will double the entire capacity. So when we talk about the built environment, right, applying digital twins and understanding the data behind that, right, we have all of that and they have all of that. But how do you predict the future? How do you simulate things? Because as soon as this new terminal opens, that's going to be here, it's going to double capacity. And at the same time, there will be exponentially more robots. So I'm going to jump now to a 3D simulation that I'll showcase, because I think this is extremely exciting technology, again, coming from the video game roots. And you can see here, this is a gate, a very photorealistic gate. So at the same time, right, I can move it. It's interactive. It's like a video game. I'm using WASD. I'm moving it around. But what if I am able to not only simulate the actions of, let's say, the baggage handling, because now I can go anywhere, right? It's just a video game. It's live. I can actually tap into all of the movement of these vehicles, right? And if I want to actually connect it with the IoT, I can. And that's really the position, right? It's really GPS positioning as well as taking CCTVs to make sure that it's facing the right orientation. But at the same time, what if scenarios? What if all of a sudden something falls down? What would happen? What would the autonomous vehicles do? Right? These are all questions that it's really hard to do in the real world, right? What if I actually put 50 of these things? Well, they optimize. And of course, this is almost a way to simulate and test a lot of the autonomous vehicles' AI. So sure, it might be just a basic visualization now, but the key thing is we can connect this to a lot of the data elements, the IoT, as well as the various different sensors together to do simulations and to also convince management that, hey, this is something that's a potential what if. Because if you want to simulate it in 2D or 3D, all of that is possible. But we as human beings need to understand it and see it before we believe it sometimes. So here's some examples. So hopefully that was useful. I'm going to jump back to the presentation, Jerry. Any questions?
No, not so much questions at this point, Eric, but obviously you're giving a master class on this, and it's intriguing and very thought-provoking. So my mind goes to all of the potential uses of this technology, particularly here in the States regarding our schools and the potential effects it could have on security and things like that. But continue. It's fascinating. Absolutely love it.
Perfect. Perfect. Thanks. Yeah, absolutely. I mean, this technology can be applied anywhere, right? Schools,
I mean,
campuses.
when you were talking about integrating it with the heat mapping and the retail applications, I keep thinking of it with an airport, how they can use this technology to significantly impact their revenue streams. So
Hmm. Yes.
is there any, if you wanted to talk on that for a second? I know that's always of interest to airport operators because, if they can increase revenue streams, it might allow them to have the available money to pay for something like this.
Well, that's the key thing is that we're trying to democratize a way that these things are being built or constructed as well as maintained. And that's really the key thing. We want to keep the barrier of entry lower. And that's really the beauty of, let's say, even AI, right? If you pay $20 US dollars to use ChatGPT Pro, or if you just want to use an open source model like DeepSeek, which I'll get into in a second, because everybody's asking me about that these days. Like this is the power of democratizing technology. And given to your point, so I'll show you what we've been actually pushing for is that, as passengers are wayfinding, is there a way to actually have them understand the different various elements of retail and what they're advertising? So again, visuals speaks louder than what I can say. And what we're experimenting with is augmented reality. We've been doing a lot of spatial computing. Spatial computing means just AR, XR, a lot of these things. So as you're walking through shopping centers or airports, one of the key things is that how do these retail stores get your attention? But at the same time, people are busy, travelers are busy. But what about the sense of the fear of missing out, especially when Crocs presents you with a 50% off coupon? Right, that's unheard of. My wife and kids will love that. But the key thing is, this is possible because you saw how everything's mapped and everything, this space right here is outside of Crocs, right? When we think about advertising, we think about Google AdWords, we think about those things. You search for Crocs and boom, boom, boom. There's first four results gives you those the advertising. But what if you're walking through a physical environment and you're looking at a 2D map? It's navigating you, but then you raise your phone up and you see that, oh my goodness, there is a promotion that's ending in 7 hours. What if I walk into it, collect it, add it to my membership rewards, and I can use it at the airport? That's powerful. And what's even more powerful is that what if this area, because it's right next to the restrooms, is high traffic area, very high heat map, very red. What if Adidas says, you know what? I'm an advertiser over there. that really brings people and moves them physically to other locations in the airport or shopping centers or anywhere. So this is the power of spatial computing technologies that we're applying all throughout the world. And we see that this can potentially be the next generation. And I'm going to really talk about that in a little bit later as well.
Hey, Eric, can I just, so just to be clear, with utilizing that technology, Adidas could advertise there even though their store's in another location of the airport.
Correct, correct. And the beauty of it
So,
is
because I
because
think some
this,
people might miss that, but keep going.
yeah, because this area is maintained by the airport, right? This space that you're walking past, right? As soon as you enter Crocs, they own that area. But the airport, as well as their tenant management, their advertising departments, can actually talk to and actually negotiate with various different tenants and say, hey, they basically become their own Google AdWords spatially, and they can actually sell this.
It's a
So
great way of
yes,
monetizing
ex-
this. Yeah.
exactly. So jumping back to the slides. So those were some live demos, but of course, the things that also, Jerry, you mentioned about the impactfulness of use cases, right? Again, ChatGPT is very useful when it comes to overview of understanding all of this. And same thing with not only predictive maintenance, right? I talked about this, how we can map every single entity, every single HVAC system connected to that, or from a seaport's perspective, berths, cargo handling, all of that can be mapped even from an operations optimization automation standpoint. Every single thing can be on there. It's already digitized. How do you actually connect the dots? And that's really the critical thing, right? And we just talked about passenger and cargo flow management. This is really critical, whether it's security or whether it's vessel planning. And of course, the emergenciness, right? How do you simulate things? How do you simulate all of a sudden it says AI-driven active shooter response? How would teams manage that, right? When we talk to Changi Airport, they're also very curious to say, well, the airport as well as the seaport, of course, is operating 24/7. It's not like they can shut down a part of the terminal and say, let's have a fire, you know, type of exercise over there. That's really hard to do in the physical world, but you can easily do that in the digital world.
So,
And of
Eric,
course, yeah.
the potentials here for this technology to be integrated into other platforms like the entrance control and all of that in a way where you could lock down sections of the physical plants,
Yeah.
isolate potential threats, and then, of course, from a risk management and forensic standpoint, and all the different viewpoints of going back and studying how something happened,
Yeah.
investigations, all of that, you would have literally everything captured and be able to determine exactly what happened and
Yes.
thereby potentially mitigating risk in the future by identifying what could have been better or how it could have been prevented. This
Yes.
technology could be utilized in, uh, American schools. That's where my heart goes. I know that
Yeah.
we're talking today about airports and ports and critical infrastructure, but I think certainly there's a discussion to be had on the potentials of how this could work with schools as well.
Absolutely. Absolutely. Yeah, and the schools are getting more digital as we speak, but at the same time, it's just not being utilized, right?
Not
In the
being
way that you're
utilized.
talking about. And that's really the key takeaway I want everybody to understand is that the data exists. Just have to utilize and map it properly. And this is not just for safety security, but at the same time, sustainability, ESG, everybody's talking about this. So many countries have signed on to be carbon neutral by 20x date, right? 2030, 2050, 2060. And that's really critical because you need to tap into that. And we actually did in my Chinese company, we did actually map out the entire smart campus of a place and to visualize and to understand every single power outlet, every single UPS system from Schneider. We even started mapping out, you can just click on, just like a video game, right? Every single object that is connected. But the key thing here also is that after it's connected, you can actually do things. For example, the car charging areas. right? Which is the most optimized way of actually driving there to get there, right? And also doing all sorts of various things you just can't do in the physical world. So just click around, you have access to all of that data instead of staring at a spreadsheet. So going back to retail, right? This is something that mentioning Balenciaga again, is that the passenger flows, even just jumping in over here, for example, let's say here's the static version, you jump in live into a CCTV and have access to your own data that's already there, right? That immediately allows even visual merchandising teams to no longer travel the world to go into every single store to make sure that they're adhering to the standards of the brand. So there's so many things that you can do with this technology. It just depends on your pain points and how do we structure it for your data. And finally, we talk about the supply chain visibility, right? What I talked about the entire world to be a simulation of your data to apply that, right? Whether it's from one port to another and where the ships are, what's going on about that. And then the most important, I think this is really the next generation. Jerry, you wanted me to cover this, is about AI, AR, and IoT. So what does that mean to a digital twin? So why now, right? Everybody's asking about this. This is critical, right? This is the largest news ever, and it's gone completely viral, right? Everybody knows about ChatGPT. I'm paying for it because, it's just it's so useful day to day. But then you got this amazing technology called DeepSeek from China coming out and saying, guys, it's free, it's open source. But what does that mean, right? All of a sudden, people are politicizing this and saying, oh my gosh, it's US versus China. But from my perspective, it's actually not. It's actually amazing that we are able to have a technology called DeepSeek. First of all, I can run it on my MacBook for free. And it runs, okay, slower than when I'm paying ChatGPT. That's fine. But I'm running it locally on my own data. And I can query it and I can generate stuff myself. That's incredible to me, right? I don't have to pay for that. And I can actually apply this to everything that we're doing, to our enterprises, to our governments. We save them money. And in a way, it's not saying that, oh, all of a sudden, NVIDIA is going to go down. I'm from NVIDIA, right? Their stock price bounced back up halfway. It's going to keep going because you know what? This only reinforces the need for these type of technologies. And talking about this, right? It's really about like how do we empower, how do we democratize technology for the world so that we can all operate better? And that's really the key thing, right? That this type of AI drivenness it can be utilized for. And I'll show you what actually NVIDIA is doing, and we're working very closely with them on how to apply this to digital twins. So rewinding and basically going to a use case where I think everybody can understand. Like, how do we design something like this? How do we, like a BMW i8, right? Back in the day, I don't know if people remember, but before software, before computers, right, information age, before that, we were just writing notes down, right, and trying to draw things. And then, I don't know, Jerry, if you use this, Lotus 123, old school, before Excel. So something like this.
I was an Excel baby.
Yeah, so that's the key thing is that I was using spreadsheets back in the day, Lotus 123, right? It was before Windows. And of course, you tally things up, you summarize data. And
Eric,
then
you
you have
don't
this
look
Excel.
that old. That's surprising to me.
It's the Asian genes. It's gotta be, man. Appreciate it.
You said
But
it.
wait, am I sharing the right thing? Oh no, I was sharing the wrong thing. My bad. Is it coming through now?
Yeah, we can see the
Yeah,
car.
so sorry about that. So earlier, so why now, right? This is why I had this visual of ChatGPT and DeepSeek and this. This is what I was talking about. So anyway,
Okay.
going to this specific thing, right? Lotus 123 over here. And then of course Excel to summarize data. And now we can actually summarize millions worth of lines of data and IoT data generated. But the key thing is it went over to 2D. All right, how do we design these things, schematics, etc., using software? And then went to 3D to design cars. And now we're actually entering an age where it's like our bodies, right? Our circulation system versus our nervous system versus whatever. It's not just a piece on the entirety. It actually makes It actually has connections. And even using what we call BIM, building information modeling of a building, we can determine the costing of every single thing, the materials, where it's coming from. Is it coming from China? Is it coming from the US, etc.? And now we're actually entering the intelligence age this year, right? This is something that is brand new for all of us. And this is the beauty of the intelligence age, is that it essentially allows you to do things that you couldn't do previously with software and AI. So over here,
Everything manufactured is
NVIDIA has been pushing this as well, my alma mater, where before ANSYS, Cadence, all of these things, they call it CFD, right? To simulate physics, essentially, took so long. All of these simulations took hours and days. But now with AI, you can actually simulate in real time. So any type of car, right? You want to change the door, you want to open the door, you want to turn it sideways, you want to add, I don't know, some new emblem, it can be resimulated instantly in seconds. And this is the beauty of the technology in the world that we're living in right now, where we can actually do all sorts of computations using AI to be completely accelerated now. And you can see here, this is all done in real time. Any type of car, any type of wheel, you just change and it changes immediately. So hours or days becomes hours, becomes seconds. And this is really revolutionizing everything. And how does this apply to digital twins, you might ask? Well, I'm glad you asked that, or at least I did. I asked that. So this is the beauty of, again, working with NVIDIA, because they're always at the forefront of this technology. So when we think about spaces, right, warehouses is a really key component, because even logistics and actually organizing all of this is really critical, right? Same thing with seaports. To simulate, to have a digital version of your warehouse and to actually understand it in the 3D world is critical, because at the same time, you can not only simulate and understand where each CCTV is pointing to, right? Visually, you can see, oh, it covers this field of view. But at the same time, you can also see that, hey, inside of this warehouse, there's people that are being simulated as well as robots, and it shows you within the next second where it's headed. This essentially gives you superpowers where you can actually access and understand. But what about those what if scenarios, right? What if something happens? It'll block paths of the robotics, and then it'll actually completely just change its route so that it can understand that. But the key thing here is not just we call it cobots, right? Working together with robots, but now using natural language, just query it, just like, hey, anything weird happen at this aisle, and they'll just pull it up like that. This is the power of where I see things are going with all of these things connected together. And this can be applied to seaports, to airports, to warehouses, and then you apply optimizations. And this goes beyond sort of the scale of what we're talking about. This essentially can not only help you optimize, because we're getting there every single day, every single week, it's getting to the point where it can be automated. So instead of you querying it, it can just automatically tell somebody, hey, there was I don't know, there's a car crash, right, at this intersection. It'll automatically notify the police or the fire department, and that'll solve and save lives. And this is the power of spatial technologies coupled with AI.
And certainly we can see that the potentials like in airport and ports, they're endless. Eric, what do you
Absolutely.
say to the executives that are listening today who think, well, geez, Changi is an airport that's an example. You've mentioned a few times that Changi's one of the best. I
Mhm.
think there's a consensus in the airport world that it really is the gold standard. Really is the best. Few people argue with that. But what do you say to the executives that say, well, this kind of technology and this kind of deployment of technology is really just for airports like Changi? Soon
Mhm.
is it going to be available both from a cost perspective, but then integrating everything that these airports have, like all of their different systems, um, all of the different departments from airside to landside to everything that goes into operations, maintenance, security, their CCTV. I mean, everything, right?
Mhm. Yeah.
Um, what do you say to those airports that would like to start the journey of modernizing and
Mhm.
improving? They don't know where to start. They don't know how
Right.
much it's going to cost. And
Mhm.
where do we begin on this? What's that discussion?
I say start with a map. Really, that's what we've learned over the last 10 to
With the
20
digital
years
map.
of, yeah, you start with that, right? If they already have floor plans, CAD files, maybe BIM files, you don't even need to go 3D. You start with that. You map out everything, and then basically you overlay one layer at a time. And that's really the critical part of where all of the technologies that we've been building and all the lessons learned over the years is that just start somewhere, right? Start with the data that you have right now, right? And to maintain the map is really critical.
Okay. And then Eric, where's the future of this? So obviously Changi has I think there's a certain advantage. They're building the new terminal, and in that new
Right.
terminal, they're able to think about integrating this throughout the building process. So it's
Hmm.
not a post build integration.
Right.
It's literally while they build, so there's an advantage of that. Would you suggest to airports that are building new terminals or new airports, to start the process literally from the ground up?
Hmm.
And then um, what does the future look like with it? What are going to be the future developments with this technology? I mean, the sky
Hmm.
really is the limit on this, but where do you see this going? That maybe perhaps in areas that you haven't discussed yet. Like for example, I think of one airport communicating with another airport.
Right.
So let's say you have an airport that has a number of connector flights, airport A and airport B. And airport B is having, I don't know, they have a runway shutdown or some sort of an issue going on here. I
Hmm.
see integration getting to the point where those communications happen. And you see where I'm going with this.
Yes.
So, talk about where you see potentially the future of all this. And
Yeah.
I know we have people on the call on the airside management that are intrigued by the potentials here as well.
Mhm. I think it's going to be more of a connected network of various, not only IoT, but also larger aircrafts of even all the baggage handling, right? Everything will be sort of queued up and optimized because let's say the space is already optimized, but then it's just like how autonomous cars are becoming very important, right? For the network in the US or in China or in Singapore. All of that is data, all mapping, as well as understanding sort of the swarm of these autonomous vehicles. So I see that over time, right? We as human beings, we as operators of these heavy machinery, we're gonna let go a little bit because we are going to say, you know what? AI is just smarter than us and faster than us. Just give it up. But at the same time, manage it, right? Utilize it, but still allow them to do their job to optimize. So I see that a lot, giving a lot of these AI-driven feedback, right? Sort of what I showed off with our Amplify platform, where it actually shows you what you should be focused on for your job, right? What's the most important thing on the air side that you should be focused on, or in the side of the terminals? So I see a lot of the data elements coming back, sort of getting processed, and then all of these, let's say, airport large language models can actually give back and say, well, this should be what's happening now. This is the sort of like how you look at Google Maps, right? You now it's giving you three suggestions based off of timing and various different routes. And it's up to you which one you want to go. So now it's going to give you those selections, sort of like I like to use the I like to use the analogy since I'm a big Marvel fan. Doctor Strange, right? He can basically see infinite pathways in the future. Well, this is essentially we're getting there because now AI will help you show you
Great
a
analogy.
potential future, right? And you get to pick your path.
So Eric, we have a question. Uh, Someone watching the webinar today, and you kind of touched this, but I want to ask the question and see if you can elaborate. Are there platforms available for smaller airports? Is this scalable for regional executive airports?
Mhm.
That's
Absolutely.
yeah.
Yeah, and
So,
that's a key thing. I think that's a takeaway, right? Don't be afraid of how much this is going to cost, because first of all, at least from what we've done, right? I mean, we're not looking at Changi Airport scale, but the thing is, because we built it as a product, it's extremely scalable and it's very quote unquote cheap to deploy because we start with the maps. If there's already a map or you want to recreate a map, right, you can actually scan it and actually digitize that, and then you start laying
well,
the
but based on
foundation.
what you're saying, Eric, airports can start now on their own. They can queue themselves up to be integratable with this technology and to,
Yes,
yeah. So, I mean, is that
absolutely.
essentially your advice is to start now?
Start now. I mean, start thinking about which various different departments that have the data that you can start overlaying, right? And I like to say that, you know what? Everybody has CCTVs. And that's why I focus a lot on that, right? That's the universal IoT essentially, but it's being utilized from a safety security perspective. But now you can use it in an operations perspective by just overlaying it on a map and to understand the spaces and what's happening. And then you can even start applying AI, where essentially you can say that, you know, it can determine when that guy at the airside gives a thumbs up, right? And says, now this is where the charging of the airlines is going to go to the airport. So, I mean, there's take it a step at a time. I think that's really the critical thing is that you don't have to go through 1 through 8, like all of those optimizations. There's no need, but take advantage of the data that you have now.
So, Eric, another question. What are the biggest technical or practical challenges in integrating AI with digital twin technology?
Yep, great question. So with AI, this is actually not trivial, I would say. So to actually connect various different data silos, you have to actually have a common machine language that communicates back and forth. And this is something that we call here at Twin Matrix the taxonomy of the airport or the seaport. So for example, like when we think about an airport, we think about the runway, we think about the markings on a runway. When we think about a terminal, we think about like a room, we think about, you know, various IoT. These are all these objects that need to be sort of condensed down to the common language. And that's something that we're actually helping solve with Changi Airport to define a natural taxonomy between various different departments so that the data can be sort of synchronized and communicated. And then you apply the AI to understand it and pull all of this data to present you with relevant information. So it's definitely not trivial yet. It's getting cheaper to deploy, but again, this requires just the IT departments to understand where the data are, as well as is there governance in place, as well as what about data cleanup. So it's not going to happen overnight. I would say this is something that every airport, seaport IT department needs to consider moving forward. Otherwise, it's going to be extremely hard to apply AI to various different layers in the digital twin.
So, Eric, and forgive the question, but I've thought about this since you started presenting today, and you might find it somewhat oddball, but I think of companies like Genetec and Ericity who have already, for years now, integrated AI with cameras, the brains behind the
Hmm.
camera, right? They've
Yep.
integrated their systems so that they take the image of the camera. They then have the ability to identify like potential threats or facial recognition and searches for people, like you have a lost child at an airport, or
Hmm.
you're looking to find a person or a container in a seaport or whatever. So how does this technology integrate, work with in a cohesive way with these other deployed technologies? Is there any incompatibility, any conflicts, or is it something where they're all integrated in kind of a seamless way where you get
Hmm.
a much bigger and better end result as a result of having it? Any conflicts there?
Yeah, I think it's really when I think about these conflicts, I think about, well, it depends on the operator sort of that's trained to use it, right? If you put yourself in those shoes, you can think about different ways of playing AI. And I wouldn't say they're conflicts. I would say that they're just ways of connecting the dots and making relationships out of the information that's presented. So
I see it more as opportunities, but
yes,
playing devil's advocate, if I'm the interviewer, and this is the case today,
yeah.
I'm going to present it in a way. Are there potential conflicts? I actually see it as more potential for opportunities, but
Hmm.
in terms of outcomes,
Yeah.
desired outcomes. So we have
Yeah.
another question, Eric.
Hmm.
What would you say are the biggest disadvantages with utilizing the digital twin space?
Hmm. I
Are there
think
disadvantages?
disadvantage, definitely. I mean, with any technology, right, there's always pros and cons. And I think with digital twin technologies is that sure, it's starting to connect more data, but we got to think about, basically safety from from cyber attacks. And that's really one of the key things in any type of organization when we think about it, right? Right now, our digital twins, right, that's being basically exposed to the world, right? We monitor cyber attacks all the time. We obviously go through AWS, so that helps a lot because that filters, millions and millions of potential issues. So I would say that before even handing the controls over, right, to the digital twin or to the AI, you definitely have to make sure all of that is figured out. Uh, you know, I think similar to a lot of autonomous vehicles, right? If the digital twin or the fleet management system starts controlling these autonomous vehicles on the air side, a lot of havoc can potentially be done. So I would say that this has to be one of the highest things to really figure out and focus on before saying, you know what, I'm going to go the full 9 yards. I'm going to do the whole thing and basically let the AI take over.
So another question, Eric, and keep in mind these are all coming from people watching and listening today. What
Mhm.
is your vision for the future of AI and digital twins in 10 or even 20 years from now? Of course,
Mhm.
in this day and age, 10 years is a lifetime.
It's a
Yeah.
lifetime. Yeah.
Yeah. So, and you start talking 20 years, I'm not certain that anyone can predict where we will be in 20 years because it's just the
Right.
speed at which we're moving right now. But
Agreed.
it is curious to know your thoughts on that. I would agree with the listener on this. Where's a guy like Eric? What do you think on this one?
I think autonomy will take over. I think robotics will take over. Right, because that's really the key thing now is that as things are starting to get connected to a digital twin that we as human beings can understand better, right? You're going to start connecting various different, not only machinery to it or autonomous vehicles, but you're going to start connecting humanoid robots. And they're obviously going to start replacing jobs. But at the same time, over the next 10 years, we're going to see huge increases in the deployment and democratization of physical AI, which is essentially robots, right? It could be specialized robots, it could be generalized robots, right? It could be just human or robots greeting people at the airport. It doesn't matter. But at the end of the day, everything will be more optimized, fluid, and more and run more autonomously. And this is really where things are going to head for sure. And
Well,
and I
yeah,
think I mean, my wish for 20 years is that if by the time that everything's fully connected and you're in charge of an airport, maybe you'll be sitting on the beach with your family, but operating and directing AI on how to manage things, right? To really free up time. Because right now we're doing a lot of repetitive tasks, and that's the biggest issue we as human beings are faced right now. Because in order to do our jobs every single day, we have to go to the computer and perform those tasks, but those can be accomplished with AI. So it's really about notifications, right? Telling you what's going on. Summarize me what happened yesterday, and then making decisions and calling your colleagues to resolve issues. So that's where I see things potentially head.
yeah, certainly it's already making us more efficient, effective, streamlining operations. It's making us better. And
Yes.
hopefully we can, as we grow and modernize, we can mitigate some of the potential risks you mentioned by being
Hmm.
laser focused on those areas, especially with cyber attacks. But the sky is the limit. It's an exciting time to be involved. I would imagine uh, you must be excited to be in the position that you're in, Eric, with this technology, and the potential it can have on all of our critical infrastructure, but particularly in transport with
Mhm.
airports and seaports. I think you're going to be a busy person in the coming years. And it's a pleasure to have had you on today. I'm going to open it up for one or two more questions if we have any, and then we will close out today. And keep in mind, Eric is in Singapore, and it's what now, Eric? After 1 or 2 in the morning there?
Yeah, 111.
Yeah.
But I
So
had my coffee, so I'm good.
yeah. Well, we very much appreciate your time today. I guess we do have another question coming in. What do you think?
Sure.
What do you think are ways that jobs in the workspace can be maintained as we make our spaces smarter and more robotic? Obviously, the
Mhm.
workforce is going to have to make some adjustments. Do you have any
Absolutely.
further thoughts on that to answer this question?
Yeah, just to be optimizing the way we do things, right? I mentioned earlier is that we're deploying apps for facilities managers to do their jobs better. But at the same time, I think that as jobs start getting replaced, no matter what, because it's completely inevitable. We all know that. We're afraid of it, but at the same time, we as human civilizations have always adapted, right, to new roles of, let's say, managing all of these things. So whether it's basically, improving the way that you're doing things, walking around, or having a robot walk around for you and basically approving it, that becomes a potential use case, or I would say a shift in the way of these roles and responsibilities get rolled out. So that's why I'm a huge proponent of, supporting AI, as well as seeing how it can benefit our day-to-day tasks. I'm also very big into gamification. For example, the mundane tasks right now that a lot of the FM guys are doing, right? If you can actually put them into leaderboards, sort of coming from my gaming roots, all of a sudden it becomes exceptionally interesting that they're competing with each other. And then that makes their lives not only happier, right, better productivity, but also it's trackable. So again, we're getting to the age where all this data, it's all oil, right? They always say that. But at the same time, how do we actually benefit our lives better, and how do we benefit society better? And that, I think that's really the key thing about the technology moving into the next generation.
Eric, thank you for today. We appreciate it. We look forward to you elaborating more on this technology and what's going on in airports and ports at our conferences this year. It's
Mhm.
exciting. Um, I wanted to ask before we close, um, are there any deployments that you can speak of? I recognize that you might be in talks and might not be able to elaborate at this point. But are there any announcements right now as to airports in the Western Hemisphere, from the northern part of the Americas all the way through Latin America, that is looking to implement this year? Or is this just um, so new still that it's just at
Mhm.
the discussion stages?
It's definitely, I would say that it depends on the maturity level, right? So we have been in discussions with various different airports, larger ones, smaller ones, across the board in Northern America as well as Latin America. But I think the key thing here is that to understand, well, this is not going to happen overnight, right? It's not just
Right.
just you just slap it on and it's going to work. So it requires a lot of consultation, right? It requires a lot of workshops to understand the pain points. And I think this is the key thing with even Changi Airport, right? It took us probably 11 workshops to understand every single departmental issues before we came up with the right solution and the right platform on our technology. And that's really the key thing, right? It's not one size fits all. It's impossible because every airport's different
Every
and the
every airport's
requirements are
different.
different. And
Sure.
and that's and that's why we look forward to actually talking with various different airports. We care about where they're going, right? Because all of this must happen in the next X number of years. But how do you get there? Right? How do you make sense of it all? How do you apply it? And really, that's where we're looking forward to discussions together more on how to solve these hard problems.
Well, and I will tell you, Eric, not only are we looking forward to having you at TMAC, the Modern Airport Conference, as well as iPort Conference, but we will work, our organization will work with you to put, there's some kind of like lunch conference day events with airport executives throughout the region this next year to get this
Mhm.
message out. So if you're listening to this webinar and you would like to have sit down with Eric, we can make that happen. Just simply contact us at TMAC and we will assist in doing so. Now this is an exciting time for us all, Eric, and thank you for putting on your masterclass today, as I keep saying, enlightening us as to what the future may bring in terms of how this technology can affect for the positive airport and port operations and all the related functions. It really is quite remarkable, and look forward to where this is going. So thank you everyone for attending today. This webinar will be available on our websites, and so you may refer to the website in the coming days for referring others to watch it. We look forward to seeing you at TMAC, and we look forward to seeing you at I this year in 2025. Everyone have a wonderful day and a wonderful week. Thank you again, Eric.
Thank you. Thanks, everyone. Thanks, Jerry.
Yeah, bye-bye now.